Two propositions, P and Q, are logically equivalent if they always have the same truth value. So we write this in this way over here, using this equal sign with an extra line on top, and so this just means equivalence. And so what this means is that P will be true if and only if when Q is true, and P will be false if and only if when Q is false. An example of that, and we'll see some examples in another video, but an example of that is the statement not P and Q. So one can show that this is actually equivalent to not P or not Q. And here, if you want to put the parentheses, that's what it looks like. So you can actually show that when for all possibilities of P and Q, the statement on the left will be true only when the one on the right will be true, and on the left will be false only when the one on the right will be false, which is essentially saying that the statements from the logic point of view, even though they might look different from a logic point of view, they are the same, right? So there are many ways of proving that that two things are logically equivalent. One of them is to just build a truth table and compare the columns. So if you go and build the truth table for P, you build the truth table for Q, and then you build the truth, and then you go and compute what is the column for not P and Q, and then you go and see what is the column for not P or not Q, and then you assign all the possibilities, true, 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 false, false, true, false, false. Well, once you do that, you can then show that whatever you get here is going to be exactly the same as what you get here, which means that in every case, this will be equal to this. And like I said, we'll see that in a later video. But for now, this is one way of showing logical equivalence. Another one is using a sort of algebra of logic, right? So the idea is that you have, after you've established rules like this, you can sort of use it, and that's why you have this looks like an equal, the negation looks like a minus, you know, and this looks like a distributive law somehow, that the minus is able to go inside, but it swaps the and to an or. So if you learn the algebra of these logic operators, you're able to prove stuff by just using an algebra of logic. So for example, you can also prove that P implies Q is equivalent to not P or Q. And so with that, you can, for example, get rid of implications and sort of try to reduce everything to a bunch of ors and ands and nots and just deal with those, right? And finally, a third way that we talk about here is you can show that P implies Q and that Q implies P. So you sort of break showing the equivalence that P is equivalent to Q into two different statements, that P implies Q and that Q implies P. And this will be quite useful when we talk about proofs. It's a common way of doing proofs. Okay, so the main idea here is that logical equivalence means that two propositions may look different, but they always have the same truth value. So in other words, you're saying that they are different ways of saying the same logical thing.